The 7 core elements of a DP system. First, sensors like gyros, wind sensors, and MRUs/VRUs for motion data. They feed real-time environmental and vessel motion data into the DP system. Gyros provide heading, wind sensors measure speed and direction, crucial for feed-forward force calculation, and motion/vertical reference units, MRU/VRU, measure roll, pitch, and heave. What to understand? You must know that if a sensor fails or gives corrupted data, e.g. a cocked gyro, it can send bad information to the control computer, potentially causing a position excursion. Key takeaway: always monitor sensor agreement and know how to deselect a faulty sensor. Operator station, OS brief. The human-machine interface, HMI, where the DPO inputs commands, monitors alarms, changes control modes, and views vessel status displays. What to understand? It needs to be user-friendly, ergonomically placed, and provide clear, immediate visual and audible warnings when something goes wrong. Key takeaway: the DPO must be completely familiar with menu trees and fast action buttons under high-stress conditions. 3. Computer/controller brief, the brain of the DP system. It takes data from the sensors and position references, runs complex mathematical algorithms, the mathematical model of the vessel, and calculates the exact thrust required to maintain position and heading. What to understand? It relies heavily on the mathematical model. If position references drop out, the system can drift off position using internal model prediction for a short period. Key takeaway: understand redundancy, how control computers switch over automatically upon failure. 4. Power Management System, PMS, brief. The system that monitors generator loads, busbar status, and heavy consumers, ensuring there is always enough power online and available for the thrusters. What to understand? A DP vessel is entirely dependent on continuous power. If a generator trips, the PMS must rapidly shed non-essential loads or blackout preventative steps to protect the thruster bus. Key takeaway: understand closed bus versus open bus, configurations and worst-case failure design intent, WCFDI. 5. Thrusters brief. The physical actuators, azimuths, tunnel thrusters, main propellers, controlled automatically by the DP system to generate thrust in surge, sway, and yaw directions. What to understand? They must respond instantly to computer commands. Key takeaway: you must know your vessel's thruster allocation, limitations, and how single thruster failures impact your capability plot. 6. Position Reference Systems, PRS, brief. External systems that measure the vessel's actual position relative to the Earth or a fixed structure, e.g. GNSS/GPS, hydroacoustic PRSs like HPR/USBL, taut wires, laser-based systems like fanbeam/Radiscan. What to understand? DP rules state you need independent systems. Key takeaway: you must understand the concept of voting and rejection. If one PRS starts drifting, the system should automatically reject it so it doesn't pull the vessel off location. 7. The DPO, Dynamic Positioning Operator brief. The human element in command. The DPO programs the system, monitors external factors, weather, traffic, operations, and takes manual control if automation fails. What to understand? As the saying goes, the weakest link in DP is often human error. Key takeaway: a certified DPO must maintain situational awareness, never become overly reliant on automation, and be ready to execute an emergency disconnect/drive-off recovery instantly. Found this useful? Subscribe, like, and share to level up your maritime knowledge the easy way. Drop a comment with what DP topic we should break down next.